teach it like a pro. Hello everyone, and welcome to your not so boring physics class. And today we will learn about speed, velocity, and acceleration. And in physics, we have what we call three motion superstars: speed, velocity, and acceleration, that all describe the motion of an object relative to a point called frame of reference. Speed. Speed tells us how fast something is moving. Speed is also a scalar quantity that has magnitude but no direction. Now let's have the formula for speed or average speed. So speed is equals to distance divided by or over time. Now some of you might ask, why is it like that? Well, speed is how fast something is moving, isn't it? So we ask, how much ground did it cover? And that's distance. How long did it take? That's time. So if you want to know how far you traveled and how long it took, you can find out how fast you were going. Okay, so now let's have a sample problem. A cheetah runs 120 meters in 4 seconds. What is the cheetah's average speed? So we know that we have our solution: speed is equals to distance over time. Now analyze the question. For distance, we have 120 meters, and for time, we have 4 seconds. That'll give us an answer of, that's correct, 30 meters per second. Because the 120 meters divided by 4 seconds is equivalent to 30 meters per second. And take note, the distance in meters divided by time in seconds will give us the unit measurement of a meter per second. Velocity. Measure of both speed and direction of an object's motion, and is also expressed in units as meters per second. And did you also know that velocity is also a form of vector quantity? Meaning, it has both magnitude and direction. Now let's have the formula for average velocity. So average velocity is equals to displacement divided by time. Now, some of you might ask again, why do we have this equation? Well, because velocity measures how fast and in what direction an object's position changes over time. Unlike distance, displacement only looks at the straight line change from the starting point to the ending point. So it can be either positive, negative, or zero, which makes velocity a vector quantity that includes direction. Now by dividing this displacement by the total time taken, we find the rate at which the position changes per unit of time, giving us a true measure of how quickly and in what direction something moves overall, no matter how twisty or back and forth its actual path was. A cyclist travels from town A to town B 60 kilometers apart in 2 hours, then immediately returns to town A in 3 hours. Now to find the average velocity, you divide the total displacement by the total time. Since the cyclist starts and ends at the same place, the total displacement is 0, so the average velocity is also 0 km per hour, even though the total distance traveled is 120 kilometers over 5 hours. The key takeaway is that average velocity depends only on the straight line change in position, not on the total distance covered. So for any round trip that ends where it started, the average velocity is always and will remain 0. Now let's have acceleration. Acceleration is the rate of change of an object's velocity. Acceleration is measured in units of distance per time and expressed as meters per second squared. The formula for average acceleration is average acceleration equals to change in velocity divided by time. Because acceleration measures how quickly an object's speed and direction change. It's all about how much the velocity increases or decreases over a period of time, showing how fast something speeds up or slows down. A car initially moving at 20 meters per second speeds up to 30 meters per second in 5 seconds. What is the acceleration? Okay, so let's plug the values. So 30 meter per second, which is the final velocity, minus 20 meter per second, which is the initial velocity. Now divided by time, and that will give us 2 meter per second squared. So let's break down the unit of acceleration. So meter per second squared doesn't mean that the object's speed is squared. It means that the object's speed changes by so many meters per second every second. For example, 2 meter per second squared means that the speed increases by 2 meter per second each second. Thanks for watching. I hope you now have a clear understanding of speed, velocity, and acceleration. These concepts are everywhere, from sports to driving, even in space travel. Keep practicing with real-life examples, and remember, physics is not just a subject, it is the science of how the world moves. See you next